Can you see the screen? Hello. Hello.
Yes, sir.
Okay. Okay, we took the example of this list, a generic list, and how it can be converted to a, or how we can derive the, the different type of classes. So from a list class, if you are given with a list class, then we can derive a stack class from it, as if stack is a list, or a queue class as if queue is a list, or a dq class where dq is considered to be uh, is a queue, is a type of queue. Okay, so in that example, we found that the list may have the methods insert begin, delete begin, insert end, delete end, is empty, is full, and display. Now the display function is required in this list to display the elements of the list, and also it is used in the stack, queue, and dq to display the contents of the data structure. Now we may decide to make it a pure virtual function, although we know that the list, once it contains the elements in this one-dimensional array, which is maintained as a circular list, once we store the values, we can just display those values. But we may decide to make it a pure virtual function, although we can add the definition of it. So that is possible, but if you don't want, you may not make it a pure virtual function. So that is up to the design. But what we want to focus is, if we derive the stack class from the list, then the point that we should consider is, in the stack, the basic interface of a stack includes the push and pop and the display, and the push and pop should be used in this name. So although pushing an element in the list can be considered to be just calling the function insert end, but if I say in a stack you insert at the end and delete from the end, it does not sound good. So the objective of while we create this stack class is to somehow hide these interface that it inherits from the, so when we write the stack, we would expect that the stack class should be inherited in such a fashion that it hides, although it inherits these methods, but it hides these interfaces, these names you cannot call, and it should come up with a different interface which is in terms of push, pop, and like display. Okay, but this push, instead of writing afresh that how to insert in the end, we can simply call uh, the one that has been inherited. So we can simply call this insert end here. Okay, so once we create a stack object, say s1, so s1 should be calling only s1 dot push, and that in turn will be calling list colon uh, list scope resolution insert end. Okay, and then if I write s1 dot pop, it will call in turn delete end, like this. But s1 cannot directly call insert end or delete end, because that is although inherited, but it is, this interface is hidden from the outside world. So how to achieve this? If we go for a public inheritance, we'll inherit and also it will be visible. Now we want to inherit but not want to make it visible. So that's why I've chosen to make it a private mode of inheritance. Okay, and if we go for private mode of inheritance, this is a kind of semantics. We can say that stack in this case is implemented as a list, not is a list. Okay, so let's just see the coding part of it. So this is the list, the original base class, and maybe we have defined it's a pure virtual function. Now I am not showing the details of these details of the methods in the list, insert begin, insert end, and all this. We assume that it is there somewhere here, or I can just include the list.h header file where everything is included. Okay, so the whole thing can be considered to be included in a header file, and I can probably write hash include list.h. Okay, so just to see the interface, I have just placed it. So now when I implement the stack, as you can see here, this is private mode of inheritance. So this is something probably you have not used, or I have not yet discussed or shown the use of it, but here we are showing it is private mode of inheritance. So this is just to show that, or also to show that, okay, private mode of inheritance is also useful like the public mode of inheritance in some cases. Okay, so the rest of the thing is almost simple. Now I define one more data member as top, because the keyword top is not as such used in a generic list, which is however uh, valid or an important keyword in terms of the stack data structure. So the rest everything it has inherited from here, but because of private mode, everything will be just masked from the outside world. So you cannot, if you use if you declare a stack variable s, so none of these work. So is.insert n does not work, so this does not work, so none of these work, although it gets inherited. So now, because objective in our case, in this case, is to redefine the interface taking the help of the inherited methods, but not to reveal them. So this part is pretty trivial, the constructors, destructors. And now I write the, now I give the prototype of the interface, and here I write the details. So in the very first line, as you can see, I have just called insert n, which it inherited, and then I have set the value of top. So top will be list end. So I am just setting the values of this the new one that I have declared here, the data member top. I'm just calling as much as possible the existing inherited methods and writing as minimal as possible in the new method that I am defining. Okay, so after the push, then I call the display also, if I would like to just use the same display. Okay, so this is how the push works, and then the pop works also by calling delete end, setting the top to list end, and then calling list display. And I have added one more additional interface which will return, if required, the value of the top. Okay, and then the display, instead of just showing it like this, I can write few more lines to have this kind of nice looking uh, say a nice looking format. I mean, the output can be shown in a nice way, as if it appears to be a stack. and once these are done, then if I write s dot push, it works s dot. So 3 times I push, then I pop, and everything works like this. So probably you can see that if I have written this linked list, the list class, so it is not a linked list, it's basically a list which actually uses an array, one-dimensional array, and that too statically allocated one-dimensional array, and it uses it in a as if it's in a circular fashion. So basically it uses these methods or this code. So once I have written this code, when I implement the stack, I do almost nothing apart from just giving the new interface as people understand or as we prefer. So is that part clear up to this?
Yes, sir.
Yes, sir.
So the one, so here I mentioned stack implemented as a list. So the thing is, so this is again, so what should be the semantic, what should be the, the name of the kind of inheritance, like private inheritance, what should be the semantic meaning of it. So these are all under the domain of object oriented design, and there are many other say discussions that what can make regarding this. Then when should you make it as a kind of relation, and when should make it isa and all this. But as you can see here, you can probably apply your intuition to find out whether I go for isa or asa, uh, maybe based on the requirement. So whatever I inherit, so first thing is you are inheriting the stack from the list, right? But whenever you are inheriting, definitely you are getting something that is either protected or public, defined in the base class. But how are you going to reveal those inherited things? Now maybe that you have inherited a car from your say father, but you just want to show as if it is your car, right? So you just register in your name, you change the color, you change everything, and maybe your relatives also do not recognize that, as if they thought that it is your own car. Okay, so you inherited, but you don't reveal uh, whatever you have inherited. So the thing is, they don't. So these inherited methods are not available in the derived class objects. Okay, so this is different from that public one, where whatever you inherit, you reveal it also. You might add, but you reveal the same also, and then you might change it, or you might add something uh, on top of it. So next we talk about the creating the or writing the q class from the list class. And here also the same, like the queue. So this will be a kind of circular queue, and in the queue we know that it inserts from one end and deletes from the other end. So in this case, and in a queue we don't uh, specify insert beginning, insert end, and all this. Rather we say that insert and delete, simple insert and delete. However, insert means in a queue means you have to insert in the end, and delete means you have to delete from the beginning. So in this case also I create two new interface or two new methods that I create in this q class after it gets inherited. However, instead of writing the entire code, I just call here inherit insert end and delete beginning. Okay, so this will be delete beginning. And as we have used here the top, we don't have anything else to declare here, because here this front, rear, and the size, they are the same here. Okay, so no more data members, but two new data member methods are added, and the display function you may modify or you may just call the same. Okay, because it is virtual, you may not change anything. If you want, you can change something, you can change the prompt, whatever. Okay. So in this case, what do you think? What should be the mode of inheritance? Although it is written here. So first of all, can we make it public?
Yes, sir.
Hello, a bit louder. Can we derive Q publicly from the list? From the list class?
No, sir.
I guess yes, sir. You can.
You may do that, but again the same issues will occur. I mean, if you inherit it publicly, then although you say that I am creating interface because whoever wants to use Q, I mean, as you have studied Q data structure, they knows that what are the operations on a queue? Insert and delete. If you inherit publicly, then all these inherited stuff here also will be revealed to you, also will be revealed to the user, and queue object will be able to invoke insert begin, insert end, delete begin, delete end. But you see that insert end is not valid in case of a queue, right?
Yes, sir.
Sorry, I mean insert begin is not valid and delete end is not valid. So do you want to derive it using public mode?
No, sir.
So even if you do that, but then it will not be very logical. I mean, the user of your class will find that there is something that we don't want. It's not, uh, although they can always use it, but they can also use this also, and that will create all sorts of problems because you want to simply restrict these call like insert beginning and delete from the end. You just want to restrict. You don't want it to be called. So the better is I just shield or mask all of them, and I would like to reveal uh, through this insert and delete the ones that I want to call. So first of all, if I make it public, then I do not get that facility to mask it, right? If I make it private, then what happens here? If I make it private, same as in case of stack, will this work?
Yes, sir. It will.
It will work, but if you have any idea of extending that class, like the Q class will be extended to DQ class, okay, double-ended queue. DQ means a double-ended queue. Like you know that, okay, I may not have asked you to implement it. Maybe in my assignments, I said, okay, you implement a list class as a base class, and then that was assignment number 1, and maybe assignment number 2 I asked that you inherit or you derive classes called a stack class from the list class, and I don't say anything. Like I know that you know the interface what should be there. I just say that derive it as you wish. And the third assignment is that I say that okay, you derive the Q class from the list class, right? So that's that entire assignment set. But you know that might be that from the Q class in some later stage I may ask you to implement double-ended Q class, DQ class, or maybe priority Q class, right? So if you would like to have that provision and if you make it private, then what is going to happen? So whatever you have inherited from this will be simply like you can use or you can call these methods here in this insert and delete, but if you inherit DQ from the queue, will these be passed here? Will you be able to pass it on if you make it private?
No, sir.
So this will be simply off, right? But in DQ, you know that in the queue, you know that it will be basically calling insert, say delete begin and insert end. But when you consider DQ, double-ended queue means you might insert from the begin and delete from the begin, and also you might insert at the end and delete at the end. So maybe that you'll be requiring these two also. Okay. So the idea is now the requirement is you would like to, so you should write the mode, specific mode, such a way or such a mode so that the list methods are inherited. That's the first condition. So the thing is, first thing is the list methods are inherited. Number two is inherited but not revealed, publicly. Okay, I want to inherit but not want to reveal publicly. But number three is any other class derived from the Q class must inherit them. Got the thing? So thing is, it's a car that you inherited from your father. You don't want to share it with your maybe relatives or your friends, but you want to share it with your children, son or daughter, right? Because it's their grandfather's property. So got the requirement, got the requirements in such case, in this particular case.
Yes, sir.
Hello.
Yes, sir.
So first thing is, if you think of this one, the second point, you should rule out the inheritance that is a public mode of inheritance. But if you want to have this also considered, you cannot make it private also, right? Because if you make it private, that means you are not going to pass it on to your children or to any other classes that gets inherited or that gets derived from that. So what is the only other option left is make it protected, and that is the use of protected. That is the use of protected mode of inheritance. Is that clear?
Yes, sir.
So this means you cannot make it public, you cannot make it private, and the only option left is to make it protected. So once we are done, so we are still focusing on Q. So we got stuck that we got the requirement, we got stuck that what should be the mode of inheritance. Okay, so once it is there, now again this list class, although I have shown it, but it should be written something like this in your code, list.h. So which includes everything, all this the interface and also the details of the functions. Now when you write the Q class, you see it is inherited in the protected mode. Okay, and then it inherits members from the list class, so the thing is everything gets inherited. But because it is protected, so you cannot call any of them. That means in the protected mode, they are treated as if they are private in that particular level. However, because they're protected, they can be passed on to to the derived classes. So because it is protected, same as that of private, they cannot be directly called from or by a Q object from outside. So they do not enjoy the facility of public mode of inheritance. That's the point. So here the rest is the same. It is the constructor destructor, which is trivial. I just define the two interface, insert and delete and display. In the insert I call list insert. So I write as minimum as possible, trying to reuse the existing code that I have already written, and list display, and here I list delete and this one. And you may or may not make some changes here. Okay, you may have a display something like this if you wish. And once you have done this, then you can q dot insert, q dot insert, q dot delete, and q dot display, whatever. So can you see the size of the code that you need to write, the amount of the volume of code that you need to write when you implement a queue?
Can you repeat that, sir?
Hello.
Can you repeat
Yes,
that?
sir.
The last part.
Sorry, I think the sound got off for a while. So I think you can see the amount of, so once you have written most of the stuff in the base class, as you keep on deriving classes, so that is how the code reusability, or the reusability helps, and that is the basic, the sole purpose of switching to object-oriented programming. So here you are not only reusing the raw functions, but you are trying to reuse as much as possible the entire. So you are using this part also. You see, you don't have to define the array and all this in begin and size and all. So you are inheriting as much as possible and trying to modify little bit as it is required, and you can add it of your own. So that is it is trying to exploit the advantage of object-oriented design. So finally, we talk about the DQ class. So
Sir?
DQ class, yes.
Sir, is this the exact internal mechanism? Means we have all the STL functions, no, sir, stack and queue. Is this how it works, or is it just an example?
No, I just took the example, but maybe when you consider a particular STL implementation, they have got, so the interface is not that minimal. So STL has got a different kind of philosophy where they deal with most of the container classes and all. So although the design is more or less the same, but the exact interface might be having something more, like the say a queue in a STL might have some more additional say methods to call. So if you think of the interface, this is probably not a standard interface. So here I focus on how you use the features of inheritance to extend your design and to derive new classes from the existing classes. That is the main focus. So this is not a hypothetical example that it will not work. It will work, but if you think of a standard way of implementing, that will have a few more interfaces in addition to whatever I am talking about. Is that clear?
Yes, sir.
So here my main focus is to show that how whatever we have discussed till now in inheritance, in dynamic in parameterized polymorphism, in a polymorphic hierarchy. So this is a polymorphic hierarchy because you see there is a virtual function. So how can we put them together, and most importantly, uh, when and in which situation we probably require private mode or even protected mode of inheritance. So this is one example where you can probably appreciate the use of protected mode also. I mean, this makes sense, right? So in the DQ, as we mentioned, that if this is a list, sorry, in the DQ you can insert it from this end, you can delete from this end, you can delete from this end, you can insert from this end. So it's like you can perform insertion deletion from both sides without restrictions, but definitely you cannot insert and delete elements from the middle. That is that is uh, uh, that is also I mean, that is still there. So in this case probably it is kind of having everything that we have here, because I'll be calling insert beginning, insert end, delete begin, delete end. So I require this, and I require this in such a way that maybe instead of writing, maybe so the same thing would have worked. I may not have created just 4 new names, each calling one of the instance or one of the methods that it has inherited, right? So insert front is basically calling insert begin, insert end is basically calling insert end, delete front is calling delete begin, delete rear is calling delete end. So I just renamed those uh, inherited methods, but maybe it makes sense if I think like instead of beginning and end, in Q terminology probably it's better known as front and rear. Maybe instead of end I can call it as rear. So insert rear, maybe like this. So you are trying to define the interface or design the interface in terms of the terminologies or I mean the understanding of the user. So the user knows that okay, DQ means you can insert in the front, insert in the rear. But if you think of the list, there is no concept of rear and front and all this. So might be that you may write it as begin and end instead of rear and, so beginning and end of the list instead of calling it as front and rear. Okay. So what I mean to say, even though they are having like one-to-one matching, but still I hide this, and I maybe reveal this one. So if I make it public, then what is going to happen? If I force it to be publicly inherited, then what do you think? All that was protected here, will they be revealed here in this level? Will they appear here? Hello? Hello?
Yes, sir.
So they will be available. And
Yes,
if
sir.
I make it public, so then this is also available and this is also available.
Yes, sir.
Okay, so maybe that this is not required, so they are all the same, so why should I allow this also to work? Now this is up to you. If you don't want it, make it private, and if you make it public, so both will be available. So I just tried to show that all the 3 modes are here: public, protected and private. But maybe a better option here could have been make it say simply private, so that these will be hidden, and you have a new interface, new names for these functions, four of those functions. But this will restrict you that you may not be able to derive another class out of it, which probably reuses whatever you have there in the base class or in these classes, right? So you don't do that. So it's up to you. I mean, based on the problem given, based on the specific scenario, you have to think that what should I do. Okay. So again, just to show it, so uh, this is the list class interface, this is the Q class interface, and probably here I just write here hash include q.h, okay, header file. which in turn within its definition it has included hash include list.h. So just including q.h is good enough, and you see that even a dq class, which is now here I have made it protected just to allow further derivation from this and still hiding the details. So the rest of the things I think it is trivial. So this is a constructor destructor, and this is how I redefine the names corresponding to the 4 methods and each of them. So insert font, insert rear, delete font, delete rear. So they more or so they look more like a DQ interface rather than a Q interface or a list interface, right?
Sir.
Yes.
Sir, in whichever scope we inherit, in whichever mode we inherit, ultimately we can use the scope operator and get all the methods, no, sir?
Here.
In whichever level.
Yes, yes, definitely. Now, see, the point is, in your base class, what entities you actually inherit? You inherit, no matter what the mode is, you inherit everything that is not private in your base class, right? Anything that is not tagged as private, because private means nobody can get a share of it, nobody can get a access to it. Neither it's meant for public use, nor it is meant for inherited classes also. So the point is, anything that is not private is inheritable, right? Now once it is inherited, now you can always use the scope resolution to refer to that name, because you are, so if it is public, then it is not only you within this class definition you can call display, but from outside also you can call display. That is the difference. So even if it is private or public, so anything that you have inherited, definitely you can use it in your own way. I mean within yourself, anything that you have inherited, protected mode, private mode, public mode, definitely you can call it here within your definition. And when you're calling it, if you want, you can specify list.display if there is ambiguity. Otherwise you can just call it like this, I mean as if with this name. But because the display is overwritten here, so that's why I'm referring to it list.display, so to resolve the ambiguity. And definitely it is true that anything that you inherit can be called using the scope resolution. Now why I do this, instead of calling list scope resolution display, what I could have called, I could have called q scope resolution display. That also I could have called, because on the top I have got the q class from which I have derived display, and I have got the display from my topmost base class also. Hello?
Yes, sir.
Any other question?
No, sir.
So here, let me just at a glance show the code which is already there. I just try to show the code. Can you see the screen? This code?
Yes, sir, we can.
Okay, so just see, I have instead of writing it in terms of header files, I have included everything here. So it does not make uh, uh, any change in the understanding. So here, this is the list class. Okay, so this is a list. As I mentioned, instead of rear and front, I could have made it beginning and end. And here, this int arr, I made it protected instead of public. Okay. So those are few changes that I made. I mean, I didn't specify what should be the tags. So these are materials protected. So in fact, all of these are protected. So thing is, from this level, you cannot access it. So you cannot create a list object. In fact, as you can see here, it's a virtual, it's a this one, this display. This display has been defined here also. So what is this display? The display is tagged as pure virtual function with some definition. Is that fine? The way I implemented it, I have implemented it as a pure virtual function with definition here. It has some definition, and these are the operations, and these are tagged as public. So you may call these. So using these methods, you may try to use this ARR, but this is not possible because you have got a pure virtual function, and this list is going to be a abstract base class. Okay, if you get into the main, if I call the list, if I try to create a list object, it should not work. Is the name fine? List. What is this? Oh, this name need to be changed. There is a space. It will not work. Sorry, I cannot show the output because I have not saved the name properly. And if I rename it, I have to restart this Ubuntu once again. Otherwise, it will not work. Okay, I think you can verify. I'll share this code. So if I create instance of this list class, it should not work. Is that clear? Why it should not work, even though it consists of a definition of that virtual function? Can you follow the code?
Yes, sir.
I cannot show you while it is running. Okay, so this is one thing. So once it is there, now I am trying to derive the stack class. So that is in the private mode. So this we have already explained. And then this is the constructor destructor. These are the different methods. As you can see here, it is calling those inherited methods. Like this. And then if I call this, all of them will work. And then if I
Sir,
yes.
sir, one point I did not understand, sir.
Hmm.
When there is a possibility that we can use a scope operator and access all the methods, what is the point of inheriting in different modes? That point I did not understand clearly.
Now, inheriting in different modes means, as you can see, if you inherit it privately, can you pass on to your, if you have, as I mentioned, so accessing, say, as I took the example of a car, you have inherited your father's car, right? So you write a father's car. Maybe your mother has also got a car. I mean, maybe it may happen. So father has, or maybe say a mobile phone. You have got your father's mobile phone and a mother's mobile phone. So that's why you write a mother's mobile phone, father's mobile, like that. Now the thing is, so that is fine. You have inherited and you want to specify it with respect to the class name, who from whom you have inherited or whose method it is. That's all. But now if you inherit, if your father says that, maybe that your father says that when you inherit from my phone or whatever you inherit, you should inherit it privately. Privately means you can use it, but you should not pass it on even to your children. But if he says that you can inherit it protectedly, that means you can access and you can pass it on to your children. If he says that you can inherit it publicly, that means you can not only pass it on to your children, but you can share it with your friends also. You got the difference?
Yes, sir.
In all the three cases, you can always say that I'm using my father's phone, father colon phone. That's all. That is always there. But whether you are going to share it with your friends who is not a part of your family or whatever, I mean, who is not you, so whether you are giving it a public access, that depends whether your father has. So maybe whenever he is sharing his property, he says that in which mode this property or whatever I am passing on will be used by my son, like that. So you can definitely use it, and if you wish you can specify from whom you have acquired it, right? That's fine. But whether you can share it to your friends, whether you can pass it on to your next generation, all that depends on the mode, and that is important. Is that okay, or still there is some doubt?
Yes, sir. Understood.
Because other than this example, it becomes very difficult to appreciate why this protected mode comes in comes in the scene. And this is just an example where I think all of us can relate to it, because we know what a stack is, queue is, dequeue is, and all this. And there may be many other examples in real life also that we can take, where this protected mode of inheritance becomes meaningful. And this is the only case where this protected keyword is used. Otherwise, private and public we have used, I think, in other cases also. But this protected is only useful when you are trying to derive something using inheritance. Otherwise, this protected does not make any sense, because otherwise the protected can simply be replaced by private. It is same as private. Okay. Here you see that this case, in the queue you have got the insert queue, the insert function in the queue, just calling lists insert end, the delete function in the queue calling delete beginning of the list, like that. So as you can see, the overhead of writing the queue class is trivial. Okay, and once we create queue objects, it works nicely. And finally, the dequeue class, it gets inherited publicly from the queue. I mean, we can go for protected mode also. Here again, why I'm writing this one? Can you say why it is important to write this using queue insert begin? Hello?
So,
Hmm? Getting my point? What is the significance of this? Can you recall, like, the use of this using keyword? I discussed about it in some of my previous lectures. Any of you can you recall when this using keyword is used? Hello?
No, sir.
So when we inherit in a private manner, or when we need to like resolve the diamond problem of inherited function, there also we used it.
So sometimes you see you have inherited privately, but you want to reveal that specifically that particular one you want to reveal. So there you can make it. Otherwise, and another case, what when there is a conflict. Can you recall the other use of using? Whenever there is a conflict that you are using, say two methods, maybe two inherited methods with the same name. Now there is ambiguity. So whose method you are going to use? So in that case, you can specify that I am going to. So if I don't specify anything, if I simply write, so in the queue with a queue object, you see with a queue object, if I call insert begin, it will be calling the version that has been defined in the queue class. But because you have inherited everything from the list also, if you would like to invoke the insert begin defined in the list class, you have to write explicitly list colon insert begin. I mean, uh, definitely if that is accessible. But in this case, what happens is insert begin. This is not publicly accessible, right? This is private or protected. So you generally cannot use it, cannot call it. But if you write here using queue insert begin, then using a queue object, you can specifically call this particular method, although the overall mode of inheritance is private. Okay, so it is something like, uh, going back to the same example, if your father says that whatever you inherit from me should be treated as private, you do agree with that. But at some later point of time you may think that, okay, let me let me make my something, say maybe the mobile phone, everything, the car, everything will be private. I don't want to share, but specifically this mobile phone I would like to share with my friends, although I have inherited the entire property privately. Okay, so this is just to show the use of the using keyword, but it may not make any sense in the context of the problem that we are implementing. Is that okay? Hello?
Yes, sir.
Is that fine?
Yes, sir.
Yes, sir.
Hmm. So now I would like to start the template. So templates is very simple. I mean, it's a pretty easy topic. So let me start a little bit so that in the next class I can complete it, next lecture. So here this is about generic coding. So what do you mean by generic coding? Maybe I'll take another 15 minutes of time. Okay, so what do you mean by generic coding?
Sir,
Hello?
sir.
Sir, the logics are written in terms of types.
Yes.
The logics are written in terms of types.
Logic is a bit louder, I cannot hear you completely.
The
Logic is the
logic
same.
is written in terms of types.
Hmm. Still it is not clear to me. Can you rephrase it? What do you mean to say? And speak a bit louder. Hello? So when I say generic coding, what comes in your mind? It's a piece of code which works for if not all, maybe multiple data types, right? So we know that C++ is a strong type checked C++ compiler is a strong type checked compiler, right? So in this case, if I write a swap code, swapping two integers x and y, okay, swap them and return okay, just swap them, swap the contents of it. So what do? I pass the reference of them and then I swap. What I do here, int x, sorry, int t, then t is stored the value of x, then x is stored the value of y, and then y is stored the value of t. Is that okay? So that's a simple function to swap two integers. So here within the main, if I call swap 2,4, sorry, I mean maybe int I equals to 5 and j equals to 6 and I comma j, if I write. So will this work? If I call this swap?
Yes, sir.
So if I display the value of I and j, will they show 6 and 5 instead of 5 and 6? Hello?
Yes, sir.
I'm passing the reference. Hello? Will it work? Am I audible?
Yes, sir.
So will it work? Can you follow me? I wrote this function. In the
Yes, sir.
main, I have declared two integers and I am calling this swap. Will it work?
Sir, it. Uh,
Hmm?
no, sir. I don't think so.
What is the problem? Anybody else? Will it work?
Sir, in the main you are passing the integers, but I guess there we are calling the address, something like that.
What address?
No, sir. It is passed by
Right,
reference.
cout I comma I and j. What do you expect will be the output here? What is the confusion? If I write cout I and j, what will be the values displayed? Now this is pretty trivial. Don't take so much of time.
Sir, it will work, sir.
Hello? Is the whole class listening? I don't know. I mean,
Yes, sir.
Yes, sir.
We are listening.
so will it work or not? First of all, will it? Can I
Yes.
make the call?
Yes,
Well,
Yes.
there
sir.
is
It will work.
confusion. Huh?
It will work, sir.
It will work. So what value will be displayed in cout I and j?
6, comma
6
5.
and
6,
5.
5. So I cannot see the name. So are you still confused? Who was telling that it will not work? Where lies the
No,
confusion?
sir. No, sir, I'm
I'm
not
passing I and j, and I'm passing the reference of I. So x is a reference of I and y is a reference of j. I could have done passing by the address of it also, but as I mentioned, instead of passing address, I can pass references and make the changes. That is what I have done. Is there any doubt in that?
No, sir.
No, sir.
Right? So this will work. Now if I call float, say p equals to 2.6 and q equals to 3.9, and I call swap p comma q, will it work?
No, sir.
Why? Because of this, right? Because C++ is a strong type checked compiler, it will not work. Although we know that automatic typecasting works, right? Automatic typecasting, does it work?
Yes, sir.
So we know that if I assign 2.5 into a integer variable, what value is assigned to it? If I assign the value 2.5 to an integer variable, what it gets? What value it receives?
Sir, to
Floor value.
So it receives 2, right? Just the value, the floor value, the 2. But in this case, it will not even do that. So it will not even consider the value 2 and value 3 instead of 3.9 and will swap it. It will not do anything. So basically the compiler is not going to call or not going to map. So it will not be mapped to this one. Okay, but this will be mapped to this one. So how to make it happen? So if I would like to have this also running, I have to write another swap with float, say f1, float reference f2, void, and the rest of the thing is same. Float, say t, then t equals to x equals to y, and y equals to t. Okay, so this is trivial. So if I write this, then this will work. So this will basically trigger to this one. It will work. Now see, if I again try to swap to characters, will any of these two work? The green and the red?
No, sir.
If I would like to swap to characters, will any of these function bodies work? What do you
No,
think?
sir. It won't work.
Hello?
It won't work, sir.
It will not work. And so characters will not be casted to float, but characters, will it work for this one? I mean, if I pass two characters, will it trigger this one? Because characters are actually stored in terms of some integer values. So do you think the characters will work by calling the first function written in blue? Will it work? Hello?
no, sir, it won't work.
If I write swap c1 comma c2, will this trigger this one? Because characters are stored in form of integers. Will this trigger?
No, sir. It won't work.
Hmm?
It won't work, sir.
This also will also not work. because of the same problem. C++ is a strong type check compiler. So can you guess the wasted effort? Wasted effort in the sense,
So you need to,
you see the entire logic is the same, everything is the same. So the only change is here. So this int and int is replaced by float, and float. And probably I'll be writing one more function to make this work, where I'll be writing the same. I have to copy this. What I have to do, I have to copy this and I have to replace this float as character like this. And not only this goes on for any number of data types, or any types of data types, any other variation of the data types. So it can be for something else, or maybe for user defined data types also. If we would like to swap two complex values to complex objects, what do I do? I have to again write one more copy. If I have to do it for two matrix objects, again I have to write. So this goes on, like the entire logic is the same, but you have to keep on copying it and then modifying those small parts. Those parts which are related to the type of the arguments, right? That may be during the input when you specify the input arguments, or also when you specify it, so in the input arguments and also in the body of the function. So wherever it has got a dependency of the type of the arguments, you have to modify those parts. You have to first create a copy of the body and modify those parts. So this is a very it's a completely wasted effort. So the idea is, in C++, can we do something better to minimize this hassle of every time writing the same logic, copying the same function, and then manually trying to replace those with the new data type for which I would like this function to work. Is there a better way of handling this?
We
so
can define
templates.
a generic class.
Yes, I am talking about functions now. So class, I'll talk about classes later on, generic classes, just simple functions. I'm just talking about writing generic functions. As you can see, so generic coding means writing generic functions that may not involve any classes. Generic functions and generic classes, both are possible. So in C++ or what is the option to do that? Because the overall philosophy is to minimize the say overhead of creating additional stuff, or so that is one thing that right from the beginning, probably through the features you learn that how the compiler eases out your your task. First thing is, you don't have to just give a different function name, uh, if you know that they are basically, intuitively they are doing the same thing. Okay, so that is one thing. Another is, okay, just a minute. Hello, হ্যাঁ দেবাশিস, আমি ক্লাসে আছি, একটু পরে ফোন করবো। হ্যালো, হ্যাঁ আমি ক্লাস করে ফোন করছি। Hello. So what is the option left? What are the options? How to write a code which is independent of type? Can you think out some option? Hello?
Sir, instead of mentioning it int or float or whatever, we can generalize it by
Now,
using
I
a
mean,
template.
if you are just a C coder, if you are just a C coder, so in C, is there any provision for generic coding? Can you write simple swap function which is generic type, or I mean some kind of code which will be acting as a generic code, but it will be a simple C coding, no additional features. Whatever you knew in the C language, can you write a generic piece of code which will basically swap two elements? Hello? Any idea in simple C?
I think no, sir.
Any other students? Once I give the answer, you will say that okay, we all know that. In C, can you write a generic piece of code? Can you see this? Then can you see this? If I write, will it work? If I write this, will it work? Hello? What is this called? What are these called? If I write hash define and all this.
Preprocessor command.
In C, it is called
Preprocessor command.
uh, uh, preprocessor commands. But what are these called?
Macros.
Macro, right? So macro is a preprocessor directive. Definitely this is process, and what is done in the preprocessor, which preprocessor means what? So this processing is done even prior to the compilation. That's why it is called pre-processing. So here processing means the processing that is done by the compiler, and pre-processing means the processing that is done even before the compilation starts. And what is done in the macro is a pre, so this hash define is a pre-processor directive. Okay, so preprocessor means even before the compilation. Okay, so what this so there is a system software called preprocessor, so which actually processes all such preprocessor directives like hash define, if def, if and def, and all this. So you'll find that in many of the commercial codes, you will find that there are lots of preprocessor directives which follows, I mean which precedes the actual codes. Okay, so in this case, for this hash define, what do you think what the preprocessor does? Do you have any idea? Hmm? Any idea what it does? So in each of the case, whenever I call this, what is going to happen? Anybody in the class? What takes place when I call this swap I comma j? So what this preprocessor does, whenever it scans through this and it finds that there is this symbol like swap x comma y, it will be replaced by. So this will be replaced by this one. This will be replaced by. So the thing is, whatever I write here will be replaced in each of the three cases. Are you getting me? So it will be replaced by. So if this is the code, so it will be replaced by this. This will be replaced by this, and this also will be replaced by this. Okay. So after the pre-processing is done, what it will look like? What it will look like? Like intij, but it will look like something like this. Okay, say let it be declared also. So maybe this case I have to declare this t. Okay, let me not get into that complexity. So this, and then this is x y, and then y is t, and then I have got the black portion which is uncompiled, then float f1 f2, and then again comes this part t f1, then f1 is f2, and then end of. Okay, are you getting my point? This way it gets replaced. So t of f1, f1 of f2, and f2 of t, t of c1, c1 c2, like this, and these portions remain. The float f1 f2, the character c1 c2, these remain. So this is after pre-processing. This will look like. So these are basically replaced by this stuff. Is that clear?
Yes, sir.
So if this happens, now this whatever I write, you may say that okay, this is not a function, this is a macro. So it's a symbol that we create, and this symbol gets replaced by this stuff, whatever I write here. That's fine, but somehow if I write this, and if the user calls swap with ij, which are two integers, swap f1 f2 which are float, and this will work, and this will definitely swap it. And if I write a cout statement after each swapping, I'll see that things has changed. I mean, they have actually swapped the contents. So can I call it as a generic piece of code? Can I call this piece of code as generic in terms of the way I define uh, uh, a, a generic code which works for multiple data types? Can we call it so? Hello?
Yes, sir.
Yes, sir. So, but how will be the type? What will be the type of variable t?
Yes, I'm not going into that. Maybe that I could have taken a uh, another example where I don't have to declare the type of t. I'm having it here. I understand your concern. So this may not be a good example, but can you see that what goes in the background of it?
Yes, sir.
I'll come to a more concrete example, which actually is valid. But can you see? Can you appreciate uh, the the generic part of the code? How it becomes independent of the types that we pass, and as
Yes.
if it appears to be a function call, although it is not a function call. This is not a function, right? This is not a function call, but it appears to be a function call which works for different types of arguments as it appears. So, right? So this is a generic code. Do you agree?
Yes, sir.
Can I call it as generic code? Hello? Hello?
Yes, sir.
Yes, sir. If we go by the definition, it is.
Yes, I mean generic means uh, anything that works for multiple types, if not all, but at least for multiple types of arguments, irrespective of their uh, type information. I mean that is what we are struggling, right? In this first slide, that is what we talked about. So why should I write another? Why should I copy the same and then keep on making those small changes and replacing the keyword float to character and float to integer and that to complex and all this? Why should I put this effort? Because it's a very stereotypical task, right? And can't I enhance the compiler in such a fashion that it does it for that it does the same thing uh, in some form? So that is what we are going to learn. But the thing is, even if I don't get any compiler support, still I can write generic codes to a certain extent. Now why I write why I say it's to a certain extent, that I'll see. But this writing, I mean using macros, we can create generic uh, codes, small generic codes we can write. So now let's take this example. Can you see this? What it is trying to do? Now in this case there is no type declaration and all this required, so it is probably it is a much better example to uh, discuss the matter that we are talking about. What it is doing, the purpose. Answer fast. These are simple things. I think now these are very simple, so please try to answer it. Otherwise it's
Maximum value.
necessarily wasting a lot of time. And if you are not getting things, just tell me. Otherwise, hello?
Yes, sir.
What is the purpose of that macro that I written?
Sir, to find out the maximum value.
Maximum. So I could have written a function also. So instead of function, it appears to be a function, because you see, so if I run this, will it work? You see, this will return 6. This will return 4.5. This will return, this will return what? 7. Okay. This will return, sorry, 5, and this will return 7. And this C out will be 6,8. So are you happy with this? Can you see that this piece of code, whatever I write, now it can find maximum of 2 integers, maximum of 2 float, and even maximum of 1 integer and 1 float. See the interesting thing. So it can have combinations of both. So 1 integer and float, that also it can compare. So the data types that it compares, the values that it compares, may be of homogeneous types or maybe of heterogeneous types. Still it works, right? But can you see some problems out of it? So all these makes you happy, right? Except this one. What is this? What is the problem here? What is the problem here?
Sir, A and B values are not modified.
First of all, what I asked here is to compare max of A and B, right? Because A was 5 and B was 6. But the thing is, so I asked to compare 5 and 6. But after the comparison, I expect A to be incremented by 1 and B to be incremented by 1, right? So what will be the final value of A and B? What should be the final value of A and B?
6
6,
and
7.
Hmm?
6 and
6
7.
and 7.
6 and 7, but it is appearing 6 and 8. And if you try to write this piece of code, you will see that it is 6 and 8. So do you expect it to be 6 and 8? So the thing is, in turn, what has happened, B has been incremented twice. And that is a kind of, we can say it's a kind of side effect. So it's a side effect. So the way we started that, we found that, okay, writing macros, we can really write generic codes. And in fact, we can write very nice generic codes. There is no problem at all. But the problem is, sometimes if you have the implementation something like this, that you can create many such side effects. So as you can see here, it increments twice. Why? When it gets, you see, if you try to replace this, what will be the replacement? Because it's basically replacement. Macro is basically replacing this piece. So this will be replaced by this piece, right? So if it gets replaced, what will appear here?
A
What
plus
will appear
plus
here?
A plus plus greater than B plus plus question mark A plus
Now again
plus
you write, sorry, it
A,
will be A plus plus, right? So A plus plus, B plus plus, and then it is
A plus plus.
A plus plus, then B plus plus.
Yes.
And this actually spoiled the whole thing. So as you can see here, no matter what it does here, but it increments B here also and here also. I mean, sometimes it might increment A also, because it depends on the larger value will be incremented twice. So that's the problem.
6-3 हो गया.
Hello?
Hmm.
So got the issue. So the thing is, definitely this one, there is no type checking as such. Why there is no type checking? In the macro, there is no type checking. Why? Because it's basically a code replacement. Who type checks? Which portion of the software, system software type checks, performs type checking? Compiler, right? Now, as I mentioned, macro is basically a pre-processed directive. It is executed even before compilation. So the compiler has not came into the uh, action at this moment when it gets replaced. So there is no question of type checking. So you cannot include type checking here, and in fact that we don't want to also. So no type checking is there, and we are happy with that, because we really do want something that is kind of bypassing the type checking and trying to replicate the code for different types of arguments, right? And that is happening. And there is no debugging facility also, because who performs debugging? So debugging is basically a part of the compilation. So the compiler says that, okay, this is an error and all this. So as I mentioned repeatedly, that this is beyond before the compilation. So there is no debugging, no type checking, everything. And this makes us happy, but at the same time, it offers with some side effects, and which is hard to remove, and you cannot probably do that. So you might say that, okay, one way of doing things is, let me uh, let me give some parentheses, but that also will not help. And in fact, I can create another instance where it will not give even the correct result also. So if I write a small piece of code where I check whether a particular value lies in a range of say L1 to L2, I can show the instance where even if it is within that range, it will show it's out of the range. So there are lots of uh, side effects that arises if you would like to write generic coding using macros. So this is a problem where this facility of writing generic codes is not adopted in C++. I mean, in C++ also you can write this, but it provides a very powerful tool to do this and to serve the objective that we are discussing, and that is what, by using templates. Okay, so template is a feature through which you can write generic codes, which is definitely, it will overcome all these phases. So it will be type checked, it will be having a debugging facility, it will overcome the side effects also, but above all it will be a generic piece of function, generic code. Okay, so let's see how it works. So first of all, can you see that? So instead of this part, instead of this piece of code, I have replaced it with this piece of code. Can you see this?
Yes, sir.
So what is this? What is this? Max function. This is basically a function. So this is a function, first of all, and it has got, I mean, it is truly a function. It's a function body that I write, but in this case, as you can see, x and y. So definitely, because I'm trying to, so I've just used a different name. Instead of max, I have called it as max func, because now this is a template function or a generic function, you can say. Okay, so I've used a different name, but the logic is everything the same. So it is so this original logic is embedded here. It accepts two arguments as it was accepting two, so it will be the a goes here, b goes here, or f1 goes here, x, and f2 goes in y, like this. But what is the strange thing that is found here is this part. So z, so I say that y is of type z and x is of type z. So z is not a defined data type, any valid data type. Now what is z? So now I say that z, so template class z. So z, you assume that it can be any defined class. So that I say. So this is what I said. So this means this function, it's a template function because it uses some symbolic names corresponding to data types. Okay, so what it does, so z is a symbolic data type. Symbolic in the sense it is just a symbol. So z can be, integer or float or character or long, or it can be complex, like it's not only predefined but also user defined, complex or matrix or anything. It can be anything. So z is basically a symbolic data type. So because I don't know what is the particular uh, data type, so I say that I just name it as z. I can write it as t also. I can write it as some other x also. Okay, so it is just a symbol that I use, and I write the entire body. Now once I wrote it, then if I write here, if I declare these two, and you see when I write max func a comma b, now this, there is no pre-processing, right? So there is no macro call, so this will be processed by the compiler. So compiler processes it. What the compiler finds, if the compiler finds a max func, now, so first thing is this will work, and in the first case, how it works, what do you think? It will report this 6. What do you think how it works? Max func a comma b. Hello, what is the type of the argument that we are passing here?
Int. Integer.
Int.
Hmm?
Int, sir.
integer type. Now this is a template. So this template is basically an outline. So the thing is, whenever there is a call to max func a comma b with integer types, what it does, you see, what it essentially does, out of it, it creates a concrete copy of a function max func with what? Int x, int y. Okay. So whenever you have this call, this will basically, this call will trigger, the compiler will trigger, and the compile, so will generate this body. So this is basically a template. So this is basically a skeleton. So if you do not call any of these functions, so in the code segment, there will be no body of such functions created. So this is very important point to note. Are you getting my point? What I mean to say? You have written this template function. This is a function which is a template function. Now, once you have written that, and if you have not called this template function with some types and all, in the code segment, you will not find any object code corresponding to this function. Is that part clear? Because it is basically a skeleton. It is just like if you define a structure, if you give the definition of the structure, or if you provide the definition of a class, so it just remains. If you have not created an instance of the class, if you have not created an object or a variable, so there is no space allocation. Are you getting the point?
Yes, sir.
So here this is just a skeleton. If you have not called any of these, no corresponding object code of this function will be actually found in the code segment. But once you have made a call with integer, instantly the compiler itself will generate a copy of this function, this I mean green copy of the function. So let it be labeled as green. So integers are green, say for example. Okay. Now again, if I say consider it to be this this blue copy. So whenever I call float, what it is going to do? What do you think? It is going to generate a blue copy of it with max func float x comma float y. Is that okay?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
So what happens here, you can see here that whenever the types are known, the compiler simply translates, creates a copy. So it basically creates a, it literally creates a copy of this, of a function body. It creates a function body out of this outline that is given, out of the skeleton. So given the skeleton, it will create this body where it will replace this z with float, because it is dealing with float. Whenever you have created this, so this int, so this z will be replaced as int like that. So up to this, if it has compiled, now in the code segment you would expect two bodies, two function bodies uh, that will exist. Now when it calls this one, what happens? Max func a comma f2. What do you think?
Error, sir.
Hello?
It will be an error, sir.
A bit louder.
Sir, there will be an error.
So why there will be error? Because you see the compiler says that okay, I can try to create it, and it says that max func, okay, there's a template, but what this template says, it says that the argument should be of
Same type.
same type. They are accepting homogeneous types, but you have passed heterogeneous type. Now because it is strongly typed, it says no, you only define the template for homogeneous types, and now you are expecting me to create a body which is of heterogeneous type. So I don't know the logic. I'll not attempt to do anything. So I'll not assume anything, I'll not do anything, I'll simply give an error message. Because, and this is the exact message that will display, that no matching function for call to maxis. There's no matching function because it cannot match even with the template also. So what it tries, it will try to find out our corresponding matching template. If the template does not match, it says that I cannot do it. Because we have written a template, because you have defined a template with consisting of homogeneous types, but for heterogeneous types, we have not defined any templates. Okay, but once we call this one a comma b, what happens? Sorry, I mean a plus plus and b plus plus. These are what types? What is the type of the arguments?
Integers.
Int.
Integer types. So again, I can say that it's a green version. So will it attempt to create one more body of integer types?
No, sir.
It's compiling from it's compiling one by one. So will it attempt to create another copy here?
No, sir.
It's already there. So finds a copy. So it's already find, you will already find a copy here. Okay, so here we can write compiler creates a copy, and here also the compiler creates a copy, but here the compiler finds a copy. And if you display the contents of A and B after this, what do you see here?
6.
Because it is A plus plus, so it passes A and then increments, it passes B and then increments. So it will display here 6, and after the incrementation it will be 6 and 7, it will not be 6 and 8. So it overcomes a side effect also in this case. So there is no side effect. Is it okay?
Yes,
Hello?
sir.
So what are these called? Each of these, what are these called?
Instances.
Instance of the template function. An instance of the template function. Okay. So how many instances a compiler will create out of the template defined? Can we say that? How many instances will be created?
No, sir.
In this particular case, it has created two templates, two instances. But how many it will create? Hello?
Sir, it
Can you
depends
say?
on how many
Yes, it
calls
depends
we
on.
make.
The thing is, it depends on how you are calling it, right? If you have made a valid call, it will create an instance if it does not exist. So theoretically speaking, it can create infinite number of instances. It can create, but it will create only those instances which are required as per the calls that you make. And definitely in that process, uh, it will see that if you are trying to create, you are asking to create a valid instance based on the template definition, and any such attempts like this with heterogeneous things, or maybe something other things that you want to that you ask to create will be simply displayed will give a error message. So just having a template function, you cannot say that how big will be the volume of the code segment or how big will be the volume of the object code. I mean, just by looking into the template function without knowing that how many times you are calling it and what are the types of calls that you are making to it, right? Now,
Sir,
yes.
sir, once an instance is created, it will be returned until the main function completes, right?
Yes, it will be written. That's not the problem. Once it is created, it will remain there. But you have to create once, and then you can. So if you have got similar calls which demands the same instance, so the compiler will not go on creating that once again. And the compiler actually does probably the similar way we do it manually also. So like copy it and then replace it like that. So we can write a small piece of code which can create such codes out of it. Now can you say, so up to this, is it clear?
Yes, sir.
So can you say if I want to make this happen, like this one which is not, so if I want to eliminate this error, so what modification in this template should I do? What modification in the template skeleton should I do so that max func a comma f2 also will work in addition to a comma b f1 comma f2 and all this. So that means what I mean to say is heterogeneous and homogeneous types both are covered by the same template. What should I do? What, where should I make any change? Anybody?
We can in the template we can define two classes, class X comma class Y. We can replace.
So one thing is, so if you, so definitely there will be not just one Z. There should, so if you call it as Z, you should be calling it as something else, maybe Z and this is T, right? And here you have to write that class Z. So Z is one symbolic class and T is also one symbolic class. So probably you have to write class Z comma class T. Is that okay for others? For the other students, got the change, got the problem that I am trying to say? So somehow you have to differentiate between these two. So differentiate between these two means you have to write here Z and here it is T. Can you see the changes? So this is Z. So this is Z and this should not be Z. This should be something else. Say it is T. And now you say that both Z and T are symbolic classes. So the way to write it is class Z comma class T, and you can have many such multiple say types, multiple symbolic types also may be involved in your code that we don't know. Okay, but in this case it is just having two distinct class types, symbolic class types, and the rest of the code remains the same. And once you do that, so in apart from getting executed this and this also gets executed. This also is fine. Now can you tell me how many bodies are created? How many actual function bodies are generated out of this template function?
Sir, will it be 3?
Hmm? How many?
Will it be 3, sir?
It will be 3, right? Because here you see this will create a, sorry, this will, so this will create a green version, say for example, and the same green version will work for this also. Okay, and maybe for this float we say maybe this one. So this one for the float, and for this particular heterogeneous one, maybe it is it's creating something like this. So 3 bodies. Function bodies, or you can say instances, template instances are created. Is that okay? And I think one is missing here, so it should be so the output I have forgotten to change. So here you will have something here. A comma f, what is a? A is 5 and f is and f2 is 5 comma 6, so it will be displaying 5 comma 6 here. It will appear here. Okay, is that fine till now?
Yes, sir.
Let me just, so it's almost done, let me show it, illustrate it with this code. So this is what we have shown. So has defined this one, and this is the template. So I have considered the latest variation which supports both homogeneous and heterogeneous type of arguments, and as you can see here, max a comma y, and this all these works. Okay, so let's ignore this part for the time being. Can you see? So it works for the homogeneous types and also for the heterogeneous type. Okay, and the nice thing that happens here is we have just written, so I'm not talking about the bubble sort, I'll be talking about later on. So this is, I've just written a single body, and you see how it nicely spawns out of it multiple function bodies. So this is basically a skeleton. From given that skeleton, given that idea, how the compiler itself will generate. So you don't have to take care of that. You don't have to take the burden of writing it repeatedly. So the compiler quite automatically it will spawn the different say bodies which will work for int, which will work for float, which will work for in float. And if I call float and then it will create one more body because it is strong type checking and all this. So it goes on like that. So when you finish the compilation, you will find that there are 3 bodies as I mentioned in this example, but you wrote just one sample, one template. So can you see the ease of writing such things? I mean, writing generic codes in C++, which is not only easy to write but also safe, because it eliminates the side effect also that arises due to use of macros. Hello?
Yes, sir.
Fine. So just one more example I took, it is the bubble sort. So the bubble sort, you see, bubble sort we all know. So this simple bubble sort, which, and this is basically integer bubble sort. You see, that's why I wrote here it's an integer bubble sort, because it accepts an integer array and then it will swap it, and using the 2 for loops and all this. So it's an integer bubble sort, and this is what you see, it's a template bubble sort. It's a template bubble sort which in this case, so can you say that where you should make the changes? Where you should make the changes in a bubble sort? In this bubble sort code, if I want to make it as a template, where should I make the changes? So instead of having the sorting of integers, array of integers, I would like to use it for sorting array of float, array of characters, array of complex numbers, whatever. So which portions of this code need to be made symbolic, like replaced by t or x or whatever. Hello?
So the end pointer to the array will.
So definitely this one, because this is what type of pointer it is, the array.
Integer
So
pointer.
it should not be integer, it should be of type t, which makes it generic. But what is this? This
Size.
n is the size of the array. So size of the array is definitely integer. So this will not change. And I and j, what is I and j?
Indexes, sir.
Will it be changed as
Indices.
t? So these are index variables, right? So index variables, will it change?
No, sir.
No, sir.
This will also not change. And what else? This is x. X is the temporary element. Will this change?
Yes, sir. That
This
will
will change.
change.
So once you write, so the thing is, when you write template functions, the suggestion is you should not start writing template and all this. So you should write first a normal function, maybe an entire version of it. You first write this one, okay, and make sure that it works. It's working. So once you find that this is working, then you try to translate it to a template function, and then what you write, then you make that. So you add this template class t. Okay, let me go step by step, then it will be. So this is just one example. So I have written the integer bubble sort. Okay, so I can ignore this part now. So I am having this integer bubble sort. It's a normal function, and let me test that whether this is working or not. So I have got an integer array, and I am passing this integer array here, bubble sort arr int. I am passing the array int with 5. I sort it, and then I display the contents. Let's see that whether it is working or not. This works 0, 6, 12, 20. So just sorted properly these values. Okay, once you know that it is working, then your task is to convert it to a template class. What should I do now? So now you write template, and you replace all those. So you have to just focus on the data types. Wherever you have mentioned data types, you have to focus on that, and you'll find out which one should you want to replace it by t. So as we decided, this should be replaced by t. This remains unchanged. This remains unchanged, and this need to be replaced by t. Okay. So hopefully it has converted this normal function, which is an integer function, to be a template function, right? So this is template function. Okay. Let's see if it is working or not. It's working, right? And just to see that, without templates, the rest will not work. That is in case of float and all, it will not work. If I just make it a normal function, only the integer only will work. You see, if I compile, it says that cannot convert float type to integer type, and these problems occur. Okay. So now, once I have done that, I written this code. So my suggestion is, when you are asked to write a template class or a template function, don't write in terms of t and x. First you write a normal, as if it's a normal function. You debug it, you check the logic, everything is fine or not. After that you identify the changes that you need to make, replace those data like data types with t or x, and in this case just one type is enough. But in the previous case, as we found, there are two types, there may be three types, whatever. So you have to write that part. So make the changes, and then once you have made the changes, now you see that so I am now trying to call all the three with integer array, with float array, with character array. So what do you think, will it work?
Yes, sir.
So when I call integer array, what do you think, what will be the output? So now now there is a kind of sorry, ambiguity. Now we have got a specific integer version of the function, right? We have got a concrete integer version, and we have got a template version. So what do you think the compiler will do? If you call int arr int, will the compiler simply call this one, or will it attempt to create a copy out of this template?
Sir,
Or will it say that, okay, it is too ambiguous and you have created you have created confusion? What do you think?
sir, as the integer version is always there, uh, it
It's
will be
already
called.
there.
It will be called, I think.
So any other ideas? I mean, what do you think? So I have written a template. So from the template, the integer version can be derived. But now I have decided to write a specific integer copy of it. I mean, integer version. I don't want. Uh, so even though I have got a template, but for the integer, I want the specific copy to be invoked and not created from the template. So will that be allowed, or it will be treated as a uh, ambiguity?
It will be allowed, sir.
Will be allowed, it seems, because yeah. So the thing is, if I compile it, okay, what went wrong?
Sir, in the template part, you did not change the type. You have written int only.
Okay, yes. Anything else? It's done. Got it. Now you see that for the integer case, because it has got a copy, so now you can decode the action of the compiler. So compiler says that whenever you call a function, no matter what you write, so now from now onwards, you know that whenever you are calling a function, whenever the compiler compiles, it first finds out whether you have got uh, a normal copy of the function or not. If there is a normal copy, it will simply link to it, and it will basically create the object code of that. If it was not there, like in the integer case it was there, but in the case of float, it was not there. In the case of character, it was not there. So in case of float, it called the template copy. Why? After creating the after creating a body out of the template, it invoked that. And for the case of character also, it found that there is no pre-existing body, so it will attempt to create it from a template. It will try to find out if there is some template available. If there is no template also available, then it will say it's error message. You have not given any clue what to do. Neither you have written a function, so it's particular error. Otherwise, if there is no body, from the template you will try to create a body. So in other words, you can say that the body might be provided by you or might be created by the from the template. But somehow, if it finds a body, it will just link with that body. If it is not having a body, it will try to create it from the template. If there is not even not a suitable template defined, it will give a error message. Is that okay? Is that fine?
Yes, sir.
Hello?
Yes, sir.
So this is these are the points to note. So template keyword is a request to the compiler to treat the function as a function template. So it's just a request. Template code is a skeleton code. It is not instantly compiled until and unless there is a call. There is a call to the template. Okay. And given the argument types, the compiler generates a suitable code instance, suitable object code instance of the function from the template. And if there exists and all, if there if already there exists a created instance corresponding to the argument types, or there is a non-template matching copy, like in this case the integer case of the function, the compiler never creates one more. Debugging becomes easy. Why debugging becomes easy? As you can see here, in this case only you have to debug this one. So if you debug this one concrete case, so you don't have to debug write a separate body and debug it separately for float type, for character type. So once you debug, you know that it will work, the same logic will work for all other data types also. And this is, so this is important to know, this is known as parameterized polymorphism. So why it's parameterized polymorphism? Because in turn, as you can see here, several instances means creating several overloaded copy. So actually what the compiler does, it is creating several overloaded copies. Even the body of the copy, the overloaded function bodies are getting created here through the templates. And this is also, it's a polymorphic behavior, because you wrote a single body, but no matter what the type input type is, it works. So that's why it has got a polymorphic nature. So it works for the bubble sort, works for integers, for float, for characters and all. So this polymorphism is based on the variation of the parameters. So that's why it is called parameterized polymorphism. I think you agree with this term also, that this is probably suitable. So this template also is a kind of polymorphism that is exhibited by the C++ compiler. Okay, so that's the end of the class. Do you have any questions? Any question? So in the next class, I'll be talking about writing template classes, and that is very simple, because once you know the basics of templates, the motivation for writing a template, and underlying syntax. So in a class also, in the next class, I'll consider the stack class. So the stack class, it was an integer stack till now we have talked about, and we have faced the problems that if I would like to, if I ask you to write a floating point stack, you would start writing the, first of all, you would probably copy the same and then try to manually modify and replace the ints with floats. But from now onwards, once you know templates, probably you will expect the compiler to do so. And the thing is, you will be writing it as a template class, as a template stack class if you write. So the same class will be instantiated to an integer stack, to a float stack, to a character stack, and seamlessly by the compiler. Okay, so in the next class we'll see the syntax of converting a integer stack class which is already there, just to make minimal changes and to replace those integers in certain places to make it a uh, template stack class, stack template class, right? And in that case it will work. So we'll see the syntax of it, and once it is done, so the templates are done. So this idea, this feature of templates has been utilized in creating standard template libraries, which is called STL in C++. And why they are called standards? Because as per the standards, it says that if you would like to, if you expect a say a stack template, so what should be the interface? So we say that okay, the push and pop and display, but they say it's not enough. So to have a very standard interface, so what is the standard interface they defined? And they defined several other interesting features also, but essentially they extend this basic idea of templates and try to come up with a very standard interface of a stack, of a queue, of like other classes. Okay, and those classes are of such generic type that using those classes, using those library template libraries, you can think of implementing any kind of data structures with minimum effort. So create an instance and start calling the methods and it will start working. So once you know how to use standard template library, writing applications using C++ codes, it will be pretty simple. I mean, it is, you don't have to write a stack from the scratch. You don't have to even write a maybe say a tree from the scratch, or even a multi-way tree from the scratch. So everything can be, or a hashing also from the scratch. So you can keep on using those templates to uh, come up with a suitable data structure uh, that you are thinking. Okay, so that's the ultimate use of C++, and it's a complete reuse of the existing template libraries. Okay, so any more questions? Okay, then I'm leaving. So tomorrow can I take a class from 11 or from 12? So I'll finish this, at least the templates will be over, and then another 1 hour lecture will be required to complete the exception handling. That's all. So tomorrow may I take 1 hour